Last video on inheritance and polymorphism, let us get right at it. Back to casting. So we've seen casting, how to cast implicitly, explicitly, and implicit casting, where if you want to take an integer and save it into a double, that can happen implicitly. Jump over here to NetBeans. If I were to say double x equals 4, I could absolutely take the integer 4 and save it into x. I could have even done this. I could have said int a equals 5, and I could have now saved a into x. That is an implicit casting or type widening. We widened the type here from the integer of 4 bytes into a double of 8 bytes. Now what about an explicit casting? What if I have double y equals 4.1 and I want to save y into x? I of course cannot do that. We learned instead that we had to therefore explicitly type the casting from y into an int. And of course this is giving us an error because we've already used x and here's z. So I can explicitly type narrow, this is type narrowing, take this 8-byte double value and narrow it and make it smaller into an int, which effectively truncated this 0.1, and if we now print z, we're merely going to get 4 instead of 4.1. So we've seen casting is the takeaway. We can also use casting to convert an object of one class to another class within an inheritance hierarchy. So that call that we saw last time, that call to method m, when we saw that we were invoking this method m that was expecting an object. And what did we send to method m? We sent over to method m, in one of the calls we sent an object, in one of the other calls we sent a student, in another call to method m we sent over a graduate student, and finally in a fourth call to method m we sent over a person. So here, for example, in this particular call to method m where I sent over a new student object, this assigns this object, this new student object, to that formal parameter which was of type object. That was the idea of polymorphism, but this was also using implicit casting. The fact that we can make a new student and save that new student directly into the most vanilla type of object, the object type. So I could say object x equals new student, and I've already created this student class, so I think object x equals new student. What does it say? Student, oh, because I need the constructor. So here we have a first name and a last name. So I can make a new student object, and because object here, the data type of variable x, because this is a super type, we can cast that, and this is implicit casting. That casting happens automatically by Java because it's polymorphism, the idea that you can save a subtype wherever a super type is expected. When would explicit casting be required? What if you want to assign the object reference O to a variable of the student type using this statement? If I said student B equals O, let's do that on the very next line. If I were to come here and type student B equals X. X was the name of this variable here. Now what's stored inside X? We absolutely know. We can see what is stored inside X is a student. Make no doubt about it. It is an object of type student. So clearly we should be able to save that object of type student into this variable B. And of course it would work if I just typed the word student there. But I did not type the word student. Instead we have object. We're saving this new student object into a variable of type object, which is more generic. But in the end, it's still a student. So why is this not working? Why do we need to use explicit casting? Because as we see, an error is occurring. So I say consider these two statements here. One of them will work, one of them will not work. Clearly, we've seen the first one works. We're allowed to save a subtype directly into a supertype with no required explicit casting. Here on this line of code, it's automatically implicitly casted from the subtype of student to the supertype. But what about this line? This one will cause an error, and the reason why is as you see here at the bottom of the slide. A student object is always an instance of object, but an object is not necessarily an instance of student. Even though we can see with our eye, it's so clear to us that we created a new student object, we saved it into X, which is of data type object, but because of that, Java's like, yeah, but I don't know what X is right here. I'm not sure. It has very short-term memory. Think of it that way. That Java's like, well, I don't know. What if X is not a student? What if X was a person? So Java's like, nope, you cannot save X into variable B of type student unless you use explicit casting. So we need to tell the compiler, look, maybe you don't realize that X is a student, but dang it, I know that X is a student. So what you do is you simply come right here and you bully the compiler and you say, damn it, no, X is a student. Trust me, I know what I'm doing. So you tell it, make it into a student object, and then all is well, and we can save it into B. This is now explicit casting, and hopefully we understand why explicit casting is at times necessary. So explicit casting, it must be done when casting an object from a superclass to a subclass. But that casting may not always succeed. Consider this example. What if you have a fruit, an object of type fruit? We have a fruit superclass, and then we have apple as a subclass and orange as a subclass. And what if we have this variable fruit? Now, we've saved into fruit an object of some type of fruit, maybe an apple, maybe an orange, maybe something else. Why may this not succeed, either of these two lines of code? And the answer is because here we don't know if fruit is an apple. Now, if we know fruit is an apple, as in this case, if we absolutely know that X is guaranteed to be a student, then we can do this with no problem. But what if X was not a student? What if we didn't see it like this and we did not know? We have no guarantee that this reference to fruit is really an apple object or is really an orange object. And so this explicit casting, it could end up resulting in an error. To avoid that, we use the instance of operator. This allows us to test whether or not an object is an instance of a particular class. So in this slide, we're back to this person example with employee. So we're trying to call this print example method that receives a person object, a very generic object of type person. Now that person could be a student or it could have been an employee on this example. So here, notice how we can use this instance of. I say if P is an instance of student, then we print, oh, P refers to a student object. It's just a teaching example. Else, if P is an instance of employee, we print P refers to an employee object. Else, finally, we could then print, no, P is not a student object or an employee object. Rather, P was just a generic person object. And this is precisely where we ended that last video, where we made within this print method of this program, we sent over a parameter, a very generic formal parameter, this placeholder that's receiving any type of object, and then we simply called the toString, and I was demonstrating that in fact we could then test this object. Was it a geometric object? Was it a circle? Was it a rectangle or a triangle? What if I get rid of all of these print statements here and I just print out, how about R? I send over just R. And now I can print. X was a geometric object. Let's copy this to save some time. X was a, X was a, X was a. This should have been a circle. This was rectangle. And here we have triangle. Format. So now when I run this code, we send over rectangle. Did I send over rectangle? I sent over rectangle, and rectangle comes right here. And what is it printing? It's printing X was a geometric object. Of course it is, because that is the most generic one. I love big brain moments. That was a fail. This goes at the end, and this is going to be your if. Of course, this is, you need to check the more, let me put an else if. We need to check the more specific. Hey, was X a circle? Was X a rectangle? Was X a triangle? Or was else just a generic geometric object? And really I could have just put here, I'll put else, curly bracket, I'll make this as a comment. So the problem was I had if X was a geometric object, print it, well, it's going to skip all of the other choices. So run this code now, and we can see it'll print X was a rectangle. Or if I sent over T, it'll print the triangle information, right? Here's the triangle information, and it prints X was a triangle. So we can use this instance of operator to check, hey, really what is X? We know that X is an object, but what kind of object was it really? Was it a circle? Was it a rectangle? Was it a triangle? And it allows us to really take advantage of that polymorphism in the generic programming that we discussed in the previous video. This is the instance operator, the instance of operator. So final tip on casting. We want to go through one more example with the fruit class and with apple and with orange. So let me open this up fully. So we have here fruit class. Fruit is a superclass of apple and orange. And apple is clearly a fruit, so you can always safely assign an instance of apple to fruit, right? If you have an apple, you can always assign it to the superclass. You can always assign orange, an instance of orange, to the superclass fruit. However, a fruit is not necessarily an apple. So you have to use explicit casting to assign a fruit object into an apple, but you only want to do so after you have first confirmed that the particular fruit object in question is in fact an apple object by using the instance of operator, and then you explicitly cast it to an apple. Equals method. Super helpful. We've not seen this yet. The object class has just a few methods that are there. ToString we've seen, which is a trash method, but we override it. We also have the equals method that is provided in the object class. That is an inherited method. It's accessible. It's a public method. We inherit it, but it's not the most valuable. The equals method, we want it to really compare the contents of two objects, but the reality is that the equals method in general, it merely compares the addresses of two objects. So what we would like to do is, in the same way that we inherit the toString method from the object class and then we immediately override it, we would like to inherit this equals method, and we want to override it to provide a more meaningful equality test. So what if we imagine we have the same program with students and with employees or other subclasses, and we want to know, do two students, are they the same? Not are their addresses the same, but is the contents, for example, of those two student objects the same? So as just one example, here is how we would override that equals method in the student class. And notice I have to send over to the equals method a parameter of type object, or it's receiving a formal parameter. That placeholder is the most generic type of object. So before we can even compare anything, we first have to check, hey, is this object really an instance of student? And how would you check if two students are equal to each other? You could check first name and last name. You could check IDs. Here we're simply checking the ID. We say, take the ID of this particular object in question, and let's compare it to the ID of this particular student object. So we've confirmed that object O is a student. So we explicitly cast O to a student, and notice the second pair of parentheses here. We then put those second pair of parentheses so we can take that casted result, call the get ID on it to get the ID of this student object, and compare it to the ID of the object that this is being invoked from. If those are the same, it will return true. Otherwise, it would return false. This is one way of doing an equals method. So here we have the equals method. I say, do note that this method receives an object reference as a parameter. So we have to first check if that object is an instance of the particular class in question, in this case student. We then cast it accordingly and we then make our method. So how can we do that for one of these? Let's check. We want to check if two circles, for example, are the same. And let's assume that we're only going to check the radius. How can we override that equals method? So right click, insert code, and let us choose equals. And here I'm going to check. It says select fields to be included in equals, generate. I want to see what they give us. Yeah, we don't want any of this stuff. I just wanted to see what they give us by default. So let me get rid of all of that. And I could have just typed it up ourselves, right? So really, you're going to have public boolean equals object O. And immediately when you do this, it's going to ask you, it's going to realize that, hey, you're really overriding the inherited equals method. So it's going to ask us to include this override annotation. So what do we want to do here, following the exact same setup of the slides? Well, this is the circle class. So we need to first check if the given object, the given parameter, O, is a circle object. That's what we want to do. So if O is an instance of circle, then we can begin to check if they're actually the same circle. But if it's not an instance of circle, of course, they're not going to be the same, so we return false. Now up here, if it is an instance of circle, we may return false or we may return true, depending if the radius is the same. So now that we have determined that O is in fact an instance of circle, what do we need to do? We need to basically take object O and explicitly cast it into an object of type circle. So I can say circle temp equals circle O. So I've taken this parameter O, I've explicitly casted it into a circle, and I'm saving it into this variable temp. And all of this is occurring within this if statement because I've already confirmed that O is an instance of circle. So now that I've done that, I can say if temp dot radius is equal to, I need parentheses, if temp dot radius is equal to this dot radius. Do what? Return true, else return false. And I know there's going to be some confusion as I type that. So before I explain this in more detail, I want to come back to the main program and our main method. I want to make another circle object. So here I made circle object. I called it C. Let's call it C1. And let's come down here, and I'll leave that one up there as C. Let's leave it up there as C actually, and I'll just make 2 down here. Let's call this one C2 and C3. C2 and C3. Let's make both of them with the exact same radius of, let's say, 15. And we can then now print do the two circle objects equal each other. We print that question and we want to print yes or no afterwards. So I'll leave that as a print statement. I'll leave the cursor on the same line. And here I want to print yes or no. How do I do that? I'm going to say C2 dot equals, and I'm going to send over C3. And that will return what? When I call C2 dot equals C3, that will return true or false. So what a great opportunity to practice ternary operators. I will print yes if it's true, or I will print no if it is not true. But pay attention here. We are calling this equals method from which object? We're calling it from object C2, and we're sending to the equals method this object C3. So this object C3 is the parameter, and we're sending that over as the parameter, but we're calling the method from C2. So right here, now let's understand this. We're saying if temp.radius, well, what is temp? Temp, oh, that's the object we sent over. That's the circle. That was C3. So if C3's radius equal this dot radius, well, what is the this? Remember, the this is the object in question that you're calling it from. So the this is referring to C2. The this is referring to C2. And so now we're checking, does C3's radius equal C2's radius? In fact, it does. Let's come back and run this code. And it will say, do the two circle objects equal each other? The answer is yes. What if instead of sending over C3, I send over triangle T? Does C2 equal triangle T? We would hope the answer is going to be no. If it said yes, I'd have to come back and look at the code. But of course, since it's not even an instance of circle, it will immediately return false. Or finally, if I put this back at C3, but I make this 22 for the radius for C3, and I run this code, do the two circle objects equal each other? And the answer is no. And the only reason it answered yes for when it was 15 was because I defined equality of the two circles as strictly checking the radius. Now, we could have defined equality as checking the radius as well as the color as well as filled. We could have done that. We could have said if temp.radius equals this dot radius and temp dot, and now we want to check is filled. If that equal this dot is filled. And then we could check the color as well. And only if all three of them are true would we then return true. That would also have worked. Similarly for triangle. If I come over here, triangle, just very quickly, now that we've done that once to show you how quickly we can knock this out. Public, Boolean equals object O. Let us add the annotation for override. And here we're going to say if O is an instance of triangle. First thing we want to do, triangle, temp equals, we want to explicitly cast O to a triangle. So now I can say if O dot, if temp dot side 1 equal this dot side 1, and temp dot side 2 equal this dot side 2, and temp dot side 3 equal this dot side 3. Guess what? If all of that is true, return true. Else, if the three sides are not the same, return false. And then finally, if the parameter was not even a triangle to begin with, return false. So this is an equals method. So now we can just use that equals method to check, hey, are two triangles the same? We have, let's make two more triangles, T2 and T3. Let's make just one of the parameters different, right? The colors are the same, they're both filled, but one of the parameters is different. Do the two triangles equal each other? And let me just change this to the triangle. Do the two triangle objects equal each other? Yes or no? T2 equals T3. The answer is going to be no, because we see that one of the sides was different. But if I make those sides the same, they do equal each other. So that's really helpful now, where we can define our own equals method to check the equality of objects. Super cool. Last major topic here, and this is back to visibility. And we're going to see a new visibility modifier, protected. We've only seen public and private, and of course default, which is when you don't use public or private. And these visibility modifiers simply determine whether or not data fields and methods can be accessed outside of a given class. If you recall, private simply says that you can only be accessed from the same class. Public, it's a free-for-all. You can be accessed, it's an open party, you can be accessed anywhere. what is protected? What's the purpose of this new keyword protected? Sometimes you would like to allow subclasses to access data fields that are defined in the superclass, even if they're in some other package. Because remember that private says you have to be in the same class. Default says you have to be in the same package. What if you're in a different package, but you're a subclass? So here we could use this keyword protected, which says even if you're in a subclass, even if you're in a different package, but if you're a subclass, we're still going to allow you access. This is what protected does. So here now we have these really 4 visibility modifiers. We have private, we have public, we have protected, and we have default. And this is where the visibility increases. The strictest level of visibility is private. Then we have default, which is basically when you don't list private or public or protected. Then you have protected, which comes next, which simply means that we can access the data everywhere except if we are outside of the class and not outside of the package and not a subclass. And then public is, of course, a free-for-all. This is a nice chart going over the different visibility modifiers. So here, public, you're accessed anywhere. Private is the other one, easy to remember. You're only accessible within the same class. What was default? Default says that we can access that value as long as we're in the same package. So we don't have to be in the same class. If you don't mention private, but you also don't mention public, default says we can access that variable as long as we're within the same package. But what if we're in a different package? You can't access the variable unless you use protected. Protected says you can be in a different package and you can access this content with the condition that you are a subclass. That's the only difference of protected. That protected, that modifier means that we can access that information from a subclass in a different package. So we saw an example similar to this previously, where we had multiple classes within different packages, and we wanted to examine what could be accessed and what could not be accessed. And we probably spent maybe 10 minutes on that video. I don't want to spend 10 minutes of this video covering this slide, page 64, but it is a super important slide. Here we have class C1 that has 4 data members, and the 4 data members are public, protected, default, and private. That's the accessibility. We also have a protected method. We have class C2, which is in that same package. Class C3 is in the same package as well as it is a subclass of C1. Then we have class C4, which is in a different package, but it's also a subclass of C1. And finally, we have class C5, which is in a different package. It's in package P2. As we see here, it's in package P2, and it is not a subclass of anything. So notice the package P2 is with this rectangle. Package P1 is with this shape here. So what we really do on this slide is we can simply, a way to study this and review this is to come to any one of these classes and just try to see what can be accessed. Once we make this, look here, we make this new object of type C1. Well, C1 had all 4 of those data members as well as this method. But from this class, what can actually be accessed? We can access X because X is public. It can be accessed everywhere. We cannot access U because U was private and was only accessible within that same class. We can access Z because Z is default, and default means it's accessible in the same package. We're in the same package. And of course, we can access Y because we're in the same package as well. What about here for class C3? It's pretty much the same thing. We are in the same package, so we can access Y, we can access Z, we cannot access U because we're not in the same class, and we can't access X because it is public. Now what about over here when we get to package P2? This is where it gets interesting. class C4, we're extending C1. We can access X because X is public. Even though we're in a different package, it doesn't matter, it's public. Of course, we cannot access U. U is private, it's only accessible within this class. But what about Y and what about Z? Well, Y is public, Z was default. Default said you can only be accessed from within the same package. Therefore, Z was accessible here, Z was accessible here. Z is not accessible by either of these classes over here in package P2 because they're in different packages. But now we can see the new difference, which is Y. What about Y? Y is protected, which means it can be accessible from within the same package. So Y is accessible here in C3 as well as in class C2. But what about in class C4 and C5? In C4, even though we're in a different package, Y is accessible. And Y is Y accessible. WHY is Y accessible. And the reason why it is accessible is because Y is protected. And protected says you're not accessible in another package unless you're a subclass. Well, check it out. C4 is a subclass of C1, so therefore Y is accessible. But when we come over here to C5, it's not accessible because it's in a different package. C5 is in a different package, and it is no longer a subclass. As I say all of that, I absolutely recognize that's a lot of information. I recognize some people are like, I don't know what he said because you turned off, and that's your choice. That is absolutely your choice to turn off. This is an important slide. If you were to take an Oracle certified developer, or they call it a Java Programmer 1 exam, you can be guaranteed to be sure that you will get several questions from this slide on that type of exam. Very important to understand the visibility modifiers. So summarizing it or putting it all together, use private when you want to hide the data members of a class completely and you don't want them to be accessible for anywhere outside of the class. Default modifiers, you use them in order to allow the members of a class to be accessed directly from any class within the same package. Public is when you want a free-for-all, it's an open party, everyone can access every single other variable. And then this protected visibility modifier is just to say, you know what, maybe we're in a different package, but if we're a subclass, we can still access you. A class can be made for really one of two purposes, either as a blueprint to create instances of that class, or for defining subclasses that will be extended by that class. So when you're doing this, your strategy should be, in general, everything should be private. As a default, make a data member private if they are not intended for direct use outside of the class. Make the data members public if they are intended for direct use by users outside of the class, and then make those fields protected if they're intended only by those who are extending that class. One more tiny thing, we're great on time, the final modifier. There are many times where you may want to just not even allow your class to be extended, which is pretty gangster to say, you know what, here's a class, you can't even extend me. If you want to do that, you can type the word final after the word public and before the class. And this means this class cannot even be extended. You cannot inherit from that class. In fact, the math class, the string class, the string builder class, all of those classes cannot be extended, and they have this final modifier. And you can also do that for methods. Methods can be defined as final, which is super gangster. That's the more appropriate usage of the word here, gangster, where because a final method cannot be overridden by its subclasses. So imagine if we don't use the word final in the class, meaning we're allowing class A to be inherited from, and in this class A, we have a method called method M, but we've made it final, which means what? That means someone will inherit this because it's public. It's a public method, so you will inherit this method. But because it's final, they cannot edit the method. They cannot override that method, which is absolutely a gangster move. So when they go inherit this method and they're like, well, I want to change it. And you're like, yeah, sorry, but not sorry. You're like, no, you can't change it. This is absolutely a nice gangster move to be able to have a class that can be inherited, but then you put the word final on one of your methods that is public. Well, that method will be inherited, but the subclass absolutely cannot override that method. And guess what? We are done with inheritance. We are done with polymorphism. What comes next is exception handling and abstract classes. Two super important OOP concepts. Going to be fun. As always, reach out, ask any questions if you have them. Take care, everyone.